You ever see something out in the world, something you see all the time, and it just doesn't quite add up? A little puzzle hiding in plain sight? Well, today we're going to pull back the curtain on an invisible force that quietly shapes our world, from huge steel structures all the way down to the breeze you feel on your face at the beach. So, first up, picture this: railway tracks. You know, they're built to be incredibly strong, to handle all that weight and speed. And yet, engineers on purpose leave these small, kind of weird gaps between the huge sections of steel. Seems a little backward, doesn't it? Why would you build a weakness into something so important? And it's not just on the ground either. Just look up at any power line. You will never, ever see one stretched perfectly tight between two poles. Nope, they've always got that noticeable sag going on. You have to wonder, is that just lazy work, or is there a really, really good reason for that curve? All right, now let's get out of the city for a second and head to the coast. If you've ever spent a whole day at the beach, you might have noticed something funny about the wind. In the afternoon, you get that nice, cool breeze blowing in from the sea. But then, late at night, that same wind does a complete 180 and starts blowing from the land out to the water. What in the world is going on there? Now, what if I told you that these three puzzles, railway tracks, sagging power lines, and those shifting coastal winds, as different as they all sound, they all share one single, kind of surprising explanation. There is one fundamental rule of physics running the show in all three cases. And that principle is called thermal expansion. It's a really simple but powerful idea. Basically, when you heat something up, it expands. And when you cool it down, it shrinks. That's it. It's not a suggestion, it's just a fundamental tendency of almost everything. Put simply, a change in temperature means a change in size. But why? Why do things actually get bigger when they get hot? Well, to get that answer, we can't just look at the surface. We need to zoom way, way in. I'm talking down to the molecular level to really see the dance that's going on. So check this out. This classic experiment with the ball and ring makes the whole effect crystal clear. At room temperature, the little metal ball slips right through the ring, no problem. But after you heat that ball up for just a minute or so, it expands and it gets stuck. It's physically bigger than it was just a moment before. So what's actually happening inside the metal? Well, heat is really just a form of energy. When you add heat to a solid, you're giving its molecules more of what's called kinetic energy. They start vibrating and jostling around like crazy. And as they do that, they push each other further apart, which increases the average space between them. The end result? The whole object just gets bigger in every direction. And this effect isn't a one-size-fits-all deal. As you can see from this chart, solids, they expand the least. Liquids expand a bit more, but gases, oh yeah, they expand the most by a long shot. And it kind of makes sense when you think about it, right? Gas molecules are already really far apart, so they have a ton of freedom to just zip around when you give them that extra energy boost. And here, you can see that liquid expansion happening right before your eyes. You've got some colored water in a bottle, and it's being gently heated. As those water molecules get more energy and spread out, the total volume of the water increases. And since it has nowhere else to go, it gets forced right up that narrow straw. It's a perfect visual of a liquid getting bigger. Okay, so we've got the science down. Heat things up, they expand. Cool them down, they shrink. Now, let's circle back and see exactly how this one single principle cracks all three of our original puzzles. This is where engineering has to be really clever. That little gap in the railway track, that's an expansion joint. On a blistering hot summer day, those long steel rails heat up and they get longer. That gap gives them a safe place to expand into without bending and buckling the whole track. The exact same logic applies to power lines. They're left sagging so that in the freezing cold of winter, when the metal wire contracts and gets shorter, it has room to tighten up without just snapping under all that tension. But here's the thing, thermal expansion isn't just a problem for engineers to solve. It's a force of nature so powerful, it can actually create weather patterns. And that brings us to our last puzzle, those mysterious coastal winds. Now, to understand the wind, we need one more little piece of the puzzle, something called specific heat capacity. I know, it's a fancy term, but it's for a super simple idea. Land heats up and cools down way faster than water does. And that crucial difference, well, that's the engine that drives this whole system. So here's how it all plays out during the day. The sun is beating down and the land heats up really fast. The air right above that hot land also gets hot. It expands, it becomes less dense, and it starts to rise. This creates an area of lower pressure over the land. And since nature doesn't like a vacuum, the cooler, denser, higher pressure air that's sitting over the sea rushes in to fill that gap. That rush of air, that's what you feel as a cool sea breeze. Then, at night, the whole process just flips on its head. As this table shows, the land cools down much, much faster than the sea. So now, the cool, dense air is over the land, creating a zone of high pressure. The sea, which is held onto its heat, keeps the air above it warmer and at a lower pressure. So what happens? The wind reverses direction, flowing from the high-pressure land out to the low-pressure sea. And that is the land breeze. So, the big takeaway here is that this isn't some obscure scientific principle you only see in a lab. It is happening constantly, all around us, in ways you might not even realize. Let's just look at a few more examples you've probably seen. You ever have a stubborn metal jar lid that just won't budge, so you run it under hot water? Bam! You're using thermal expansion. The metal lid expands just a tiny bit more than the glass, and that loosens its grip. Or what about Pyrex glassware for cooking? That stuff is designed with a super low rate of thermal expansion, so it won't crack when it goes from a hot oven to a cool countertop. It's even used in super precise instruments, like old pendulum clocks, to make sure they keep perfect time, no matter what the temperature is. When you really step back and think about it, it's pretty amazing. This one simple idea that things get bigger when they're hot, it explains so much. It connects everything from the tiny details of opening a jar in your kitchen to the huge invisible currents of air that create the climate for entire coastlines. It really makes you wonder, doesn't it? I mean, if something as basic as a change in temperature can move enough air to create winds that stretch for miles, what other powerful, unseen forces are out there right now, quietly sculpting our world in ways we haven't even begun to notice yet?